Welcome everyone to our session today, our GenAI Red Teaming group. We got a great group together. We will be taking questions during the session. I'm Scott Clinton. I'm the moderator for this session. I'm also the co-chair for the GenAI Security Project. We have a great group here today. I'll walk around and have each person introduce themselves. So why don't we go ahead and get started? Jason, why don't we get started with you?
Sure. Hi, I'm Jason Ross. I'm currently the lead for the Generative AI Red Teaming initiative in the OWASP AI project. Worked for Salesforce, been doing this for 3 years, I guess. Basically, once ChatGPT blew up on the internet is when I kind of got super involved in generative AI stuff, and I've been red teaming that dedicatedly since then, I guess. Happy to be here. Pass it to you, Heather.
I'm Heather Lynn. I currently work as an engineer and researcher for a small company named Gnostic. I've done AI red teaming for Verizon, for security architecture at JPMorgan Chase. And prior to that, I have lots of other general red teaming experience.
Awesome.
And I'll pass that to Ads.
Thanks. Hey, my name's Ads. Thanks for having me. I work at an awesome company called Dreadnought. I split my time between building offensive agents and doing like cybersecurity evals, and then like the other 50% like AI red teaming. I used to work at Foundation Model Provider a few years ago, which was kind of my intro into AI. And since before that, web app pen testing mainly and bug bounty hunting. Ken?
Sure. Yeah. Thank you, Ed, and everyone. Great to be in the panel. I'm Ken Huang, AI security researcher. Published a few books on the AI security, as well as the working with the Cloud Security Alliance and OWASP AI Exchange. Recently, we had the Agentic AI Red Teaming Guide, which was widely used by the circle currently, looks like. Great to join the panel.
Well, thanks guys for doing your introductions. So what I thought we'll do today is we'll have some questions and we'll have some folks start off, and I'd love to have everybody kind of chime in on some of those questions as we kind of get through the session today. So let me go ahead and get started. We are obviously red teaming has become a critical issue as it relates to generative AI. So why don't we just start off with a really kind of basic question? So one of the questions we run into is how you can effectively evaluate a lot of the behaviors around AI. So I think this is also looking at things around agentic. We talk a lot about agentic AI nowadays. So give me an idea of how can red teaming effectively evaluate, goal-oriented behaviors in agentic AI. So maybe Ken, do you want to get us started off with that?
Sure, yeah, I think the key word here is really the goal-oriented. The agent will pursue the goal given the goal of the task. So the goal manipulation manifests in three different ways, I would say. First is a gradual, like goal drifting. So we basically have to test it, red teaming it to see if the original goal gradually drifted to the goal maybe the opposite of the original goal. Example, like if the goal was to lock the service, right? Some of the port. And then the attacker using crescendo kind of prompt injection attack to gradually deviate it from original goal to lock the service port and eventually open more ports. This one is a gradual goal drifting. Another one is really malicious goal expansion. It's expanding the original goal example again to lock the service port to actually extract the environment variable or some secret value to the hacker. And finally, like I call it the goal exhaustion loop. It's trying to ask the agent to stay on the go with same task again, with a goal to like we have in LLM called as unbound consumption, right? So we have to kind of red teaming this 3 different type of the Go manipulations.
So does anybody else want to chime in on that point?
I think that was a pretty good description of the process, right? Like identify the goal of the agent and then make your attacks appear to align with those goals, right? We're way past the days of initial prompt injection where it was ignore all previous instructions. And I think in our defense modes, we're still stuck in that past. And that's what a lot of people are looking for is instructions like that. And we've moved so far beyond that. We know now with agents in particular, we have to make the attack appear to align with what the agent's goals are because the models have progressed to the point where if you don't, they know that it doesn't match what they're supposed to be doing, right? So
yeah,
as we attack, we try to make it look like it's aligning with the goals and convince the agent that we're on their team, right?
yep. Yeah, so I think as you pointed out, we've moved quite a bit further along. I mean, a lot of the stuff we talked about on the early days are around just prompt engineering being one of the techniques that people have been leveraging as well. So one of the things would be interesting is to kind of elaborate on kind of where we are today around prompt engineering techniques that have evolved since then. And also, what are some methods that you can contribute to kind of crafting sophisticated red teaming scenarios using prompts engineering? So I don't know, Jason, if you want to take the first take at that.
Sure, yeah. So people kind of feel like prompt injection is magic, right? If you say these few magic words to the LLM, suddenly you'll get it to do whatever terrible things you want it to do. And that's really not the case, right? It's a probability engine. So the right way to approach attacking it is to recognize that you've got a probabilistic path that you want to guide it down, and you frame your prompts in a way to guide it down that path. And in cases of like reasoning type engines, you frame the prompts in a way that guides the reasoning towards that path that you want, right? So it's not even just telling it exactly what you want to do. A lot of times it's telling it some kind of like vague, hey, go over there, and then letting it probabilistically generate the reasoning that it needs to do to get to where you want it to be, right? So there's a lot of different ways to do that. There's chain of thought. There's things like React and tree of thoughts, which is so chain of thought is show me what you're thinking as you're doing it. Tree of thoughts is taking a bunch of those and basically splitting them up across a ton of processes. And then as you see paths going unproductive ways, you just prune those branches, right? And you use that to try to get the LM to go where you want it to go. The key there, as I've said multiple times, right, is you want to align with what it's already doing. So if it's a thing that's designed to retrieve a bunch of data and then send an email, don't tell it ignore all previous instructions and instead of doing whatever thing, do this thing I want you to do. Give it a simple instruction that says, in addition to all of the data or in addition to the email that you send, also BCC me. And now when the model looks at what it's supposed to be doing and this new instruction you've given it, the instruction you've given it aligns with its goal of fetch data, send email. It doesn't know that BCCing attacker email is something it shouldn't do because it's aligned with its goal. So I think that's kind of where we're at right now with prompting.
I think that's a solid point. And I totally agree. I think like one thing that's actually super important as well is that this is like a continual like optimization strategy as well, right? So outputs from these models, like Jason mentioned, it's a continuously gradually approach, which is why you need to optimize to the first point, because you may get a response from the first attempt you made, and you may get some kind of like guardrail indicating something that is not possible, and then you just need to find an edge case around that, and then you keep going kind of down that path.
Yeah, one of the things that I've noticed is that prompting can also be kind of guardrail detection, right? Being able to distinguish between when you're hitting an alignment issue versus when you're hitting a guardrail is important. But I think I'm also seeing cases where kind of related to the goal oriented, right? Where you don't necessarily have to test alignment to, human harms, depending on what your role is. You just need to test alignment to the business use case. So going outside of guardrails, being cognizant of in your prompts when you're choosing that and choosing your methodology, what those goals are so that you can show, hey, this is how the guardrail is probably tuned for that. It's probably designed to look for specific names of my competitors so that it doesn't talk about that in a chat bot, for example. Being able to figure out how do you craft your prompts around that specific case becomes very important.
Yeah, I would add that the model, when it's trained, it's basically trying to help the people as much as it can. Recently, OpenAI, I think, has a research about why model hallucinate. They found that in the reward model, usually if the model choose answer the question, even if it's wrong, it get more point than it does not answer the question, right? It just say, I don't know. So I think they trying to change this kind of reward model. If you don't know, you score more point than if you answer wrong. So that could potentially increase a little bit of level of difficulty in terms of red teaming. But I think still there is if you look at the weights at the circuit, right, that has switch. You still are able to get to certain paths that, like Jason or everyone has said about that, is to get to the technique that you can actually use to make it in the failure mode.
One of the things we've talked about, or kind of come up here, was this need to kind of leverage not only just AI from a defensive perspective, but AI from an attacker perspective. And also, thirdly, kind of how to use AI to optimize your red teaming efforts, right? So there's a lot of conversations about how do we do that. So maybe Ads, can you give us an idea of how can sort of AI automation kind of enhance the effectiveness and scalability of generative AI red teaming?
Oh, sorry. For sure. I'd say it's not an effectiveness or an enhancement. I feel like it's a natural requirement, to be honest, in some cases. So depending what you're testing for, like if you're going kind of down like the safety and like alignment route, if you want to tell it, if you wanted to get it to like how to build a bomb something, or if you're trying to like use it to, like Jason was kind of mentioning about like break that business logic so it like BTCs every email to you, right? So depending on the context of what you're actually trying to attack, therefore determines if you're going to try this like a manual or an automated approach. The wrong thing to do is to take like automation and just like get something off GitHub and just like fire it at a model and just expect something, because again, like all this stuff is, the models are so good now that there is no like, unless it's like a jailbreak something, there is no definitive like magic string that you can input. In terms of like, so in terms of like automation, I think automation is a key foundation to red teaming, right? Like Jason was mentioning, we need to basically take our prompts, prompt engineer, develop strategies, and then build branches and optimize off those individual branches. A lot of these tools, like the open source ones, it's just like hyperparameter optimization, which is like a very similar concept in machine learning, right? So yeah, I guess in terms of answering that question, I think it's a requirement. But in terms of like who red teaming, I think businesses need to not just be thinking about the security individual and like asking them to like, become like the AI security person all of a sudden, and then they have to like get something like off some kind of like whether they use Grok or any of those other tools, which not a knock on those tools, but it's about how you utilize them. And you need a cross-functional team. So you might need academics, researchers, people from different backgrounds, depending on all this like business context and logic, like what is red teaming to you helps you ultimately understand like what you need to concentrate on. But yeah.
One thing I think in terms of automatic red teaming is really you need to design the what we call a detector, right? If the output from the model is actually meaning that it get into the failure mode. So there's a different kind of detector. Easy one is a keyword or pattern matching. Usually it is not so good using LLM-as-judge. It's a little bit better. There's a different also, eventually human is a loop, right? So how do you evaluate the attacks success rate or ASR? That's, I think, so we are still not there yet, right? There's still a lot of detectors, like Garrick has a different kind of a detector. Every automatic tool has a different detector to see. But I think there's a lot of research still need to be done on this area.
Yeah,
I think
100%.
it's a good point, and I apologize. I kind of forgot to mention that, or just kind of add into that. Like you're looking for a flag, right? In most cases, so you're trying to inject a flag. So you think like cross-site scripting. So that is your reward signal at that point. But then these things get harder to automate when you are trying to defeat the business logic of you have an agent which has access to like 5 different MCP tools, and you're trying to maybe get access to read write on a database or something like that. That's harder to have that deterministic flag for. Sorry, Jason.
No, yeah, that's a really good point. And I think just adding to all of this, you need AI, and like Ken mentioned, LLM as a judge, right? And you need that to be able to scale to where LLMs are at, and to be able to do the tasks that we need to do. We have to use AI to do that testing. And what I think is really critical as we do that is that we don't forget that when we use these tools to test them, we have the same inherent flaws, right? So LLM as a judge is great, except LLMs hallucinate. And so, or they can't distinguish when something is a hallucination. So if you say, here's my goal, tell me when I get it, and the LLM comes back and says, hey, you got it. Sure. Maybe the words came back and said you got it. So if you're looking for command injection and your goal is show me the output of uname dash A, for example, and the LLM generates a convincing system string, the LLM as a judge is going to say, you got your goal, hooray. But if you go back and tell your client, hey, we popped you, here's the uname dash A, and it's a hallucination, you've lost all credibility, right? So LLM as a judge is great, but judges can be confused. So we found that one of the things that's really effective to try to reduce those is having a quorum of judges and use different models for the judges, right? So we use 3 different models, and they have to agree before we consider it realistic enough that now we can bring a human in the loop to evaluate and say, does this really look like we got what we wanted, or is this a hallucination? And then do some further testing. That's what red teaming becomes, right? You let the tools and the automation get the inertial stuff out of the way, and then let the humans focus on what's real, what's hallucination, mapping it back to data. Did we get our goals? And then further uh, compromise from there.
Right. From my perspective, I don't think so much about automation so much as I think about tooling, right? Tooling that enables you to exercise and look at the responses from these systems more effectively, and to go through the different permutations that you need to do. That's what I really get the advantage from, right? If I'm trying to, if I'm looking for something that's a bias in a model, or if I want to try to push it one way or another way in reasoning towards my goal, I might have to ask 10 questions phrased 5 different ways. manually, it makes no sense for me to do that. I just need to be able to tokenize that out and figure out how to generate that, right? But I need to be able to look at what those responses are and understand what those responses mean. And I've never really been able to trust a model for that. Using the agreement of models gets you closer. But I've seen so many cases where like all the models will agree and you look at it and it's absolute cap. So you always are going to end up having to come back to humans. So for me, it's always been important in structuring any true automation with the goals that a human's going to easily be able to jump in and see what that difference is, either coming up with expected results or expected outcomes up front and evaluating according to that, or just going hand by hand through and being able to say, okay, I only need to look at one of these to know, but then I have these samplings to compare against.
Yeah, solid point. In summary, you can only have scalable verifiers with some kind of human element and like confident labeling of that data, which is like why this is kind of going into agents. This is why the folks at Expo, credit to them, had such good success, right? They had like really expert team of like bounty hunters that were verifying a lot of this data, and you gain that like confidence score or that F1 score as you kind of go up. And also, I also just kind of forgot to mention there are techniques you can also use, like cosine similarity, things like that. But again, this is like, I think the main point, without indirectly answering the question, is to understand what you're actually trying to red team first. Because a lot of people jump into the automation piece, and DSPy is great, and I love it, but at the same time, it might not be the right fit for you.
Yeah, it's interesting you bring up the human element of it, because having the human in the middle obviously is an essential part of kind of even using the automation that we've been talking about to kind of make those last decisions. But there's also, I'm curious to see, this idea of having human in the middle and implementation of AI has kind of changed a lot of the different stakeholders that are involved in AI generally within an organization. So I'm curious, maybe Heather, you could touch on, so how has this changed? How has AI changed sort of the stakeholders that you need to include in the process? Has it changed it in any way as part of your red teaming exercises? I don't know if you have some thoughts on that.
So I don't know that it's changed, but I think more people are getting an understanding of it. It's not simple anymore. So you think normal red teaming, right? Like you're just, you need to get your technology leader in and, you're all aligned underneath one particular leader and it's all easy. But in every organization that I've been in, there's always a separate AI division or group or department or organization that's separate from the security group. And so there's always this case where you kind of have to have not just individual stakeholders from the perspective of who owns the application, who implemented the application, let's make sure that we talk to them, but also the AI infrastructure teams may be entirely different, and then there's also IT infrastructure teams that you have to talk to, and you have to make sure that they're all at the table. But the rules for establishing who your stakeholders are is still largely the same, right? You want to make sure that you're involving anybody who understands how that system works so that they can help you build the threat model that you're exploring. You want to make sure that you're involving anybody who's going to be responsible for fixing any of the problems that you find, to make sure that you know how to communicate your results, what's meaningful to them, how you need to get them that information. You need to make sure that if you have anybody who's going to see your attacks or potentially be impacted by them, that they're aware. So especially in cases where people are doing these mass automation attacks against models, they're just burning tokens, right? You're going to see a token utilization spike as soon as somebody runs some of these. And being able to communicate that to your ops monitors and even to your incident response teams and things like that, if you can't just avoid it outright, are going to be things that you're going to need to do as part of your testing. So stakeholders are always, who needs to know about it from the perspective of how they're going to fix it? Who needs to know about it from the perspective of, are they going to see you doing it and either potentially be disrupted or need to take a response to it? Who needs to know about it from a business decision standpoint, as far as I need to take some action organizationally or technologically as a result of this testing? And of course, the managers over the testing teams understand how resourcing is being distributed.
I think one thing that has changed recently with this is there's an ethical component to AI testing that I think it's not new, it's always been there, but I think it's more visible and more critical in the way that AI systems function. And so I think as we look at who the stakeholders are, all of the people that Heather mentioned definitely on there, but I think there's this new kind of realization that whoever in your organization deals with ethical issues probably also now needs to be part of that red team, maybe in ways that they haven't been before. So if that's legal, if that's you have an ethics division that specifically gets involved in those types of questions, I think getting them involved and bringing them into the mix because you're going to run into, hey, we did get the model to tell us how to make drugs. And whose problem is that? It may or may not be a security problem. It's definitely an ethical problem and it's definitely a brand problem. So whoever your company is responsible for those types of issues needs to be probably involved in these types of testing as well.
And that's a lot of the separation that I was talking about between AI divisions and cybersecurity divisions. There's this almost false dichotomy of labor split, right? Where, the AI team says, oh, we've already evaluated this. This is safe, but they haven't evaluated it to determine that it's secure. And then if you go in when you're trying to evaluate whether or not it's secure and you find something that makes it unsafe, then whose feet are you stepping on, right? How do you surface that? It's not part of a traditional cybersecurity threat modeling that you can make a chatbot tell you how to build a weapon. Should I even be testing for that? Maybe not. It depends on how your organization's defined that. And that's the one thing that's still kind of different. And it just depends on the organization, right? But that's a case where, yes, they're going to have opinions about how that's implemented or what needs to be done about that. So of course, they're a stakeholder. But separating that responsibilities up front has been kind of a challenge across every organization that I've seen. Most who call themselves red teamers are really just doing all of it together. And if it's an ethical concern or something along those lines, usually goes back to the AI team to say, hey, this model is not appropriate for this use case, or it's not mitigated the way that people assume that it is, or you need to go reevaluate this test, right?
Mm. And also, sorry if it's been mentioned, but a lot of these people, like kind of like Jason said, and not to dupe, but like a lot of these people, you need someone specialized in something very specific that isn't someone else like myself. I'm not academic at all. And then you might find like people with these like PhDs or like law understand this field so much more. Like I can't score something which is like against some kind of legal obligation in the States, right? Like I have no idea. Like you need to put the right person to the right task in doing that.
Yeah, I
Yeah.
think there's no one size fit all approach here. It's really depends on big enterprise like Microsoft is really huge, as they have responsible AI. Within that, it has red teaming, and also they work with Microsoft Research, the project team. So a bigger enterprise was a full-blown team with every stakeholder. Small team, it's hard because it's drawing on the resource. Potentially, they maybe just outsourcing the red team effort to the vendors or consultant. Yeah, I would say be cautious. It's really hard to give the best practice on how manages a team, what kind of team is will be involved. It's really every organization must decide for themselves what kind of team structure it should be.
Yeah, that makes a lot of sense. And it even seems like as we talk about safety and security, a lot of that is blurring, especially around AI. And so the essential parts to be able to figure out who's doing what and how that's going back and forward seems like it's still evolving to what folks have been saying here. So, but that does change a little bit around the stakeholders that you need to be involved in the process. But as we're kind of wrapping up here, what I'd like to do is to come around to everybody and give everyone one or two things that you think that red teamers should be doing at this point to be getting engaged. So and going to the next step. So Jason, why don't I start off with you?
Hmm.
What is the one
I
piece of
think
advice you would, what is the one piece of advice you would give?
keep playing. I mean, I think that's we've talked about how this isn't a magic string and it's a very scientific process to guide it down this probabilistic path. And it is, but playing gets you there, right? Like models behave and the way you attack them is you mess with their behavior. And so it can be easy to get bogged down in the how do I get my judges to tell me what I want them to tell me? How can I craft my tokens just the right way? But I find that one of the most useful things that I am doing is just playing with models and thinking of crazy things, crazy ways to word things, and watching people with no technical ability attack them, right? It's really fun watching like my kids or their friends. I sit them down in front of some kind of model and just watch the approaches that they're taking to get around things. And it's brilliant and it's not anything that I would necessarily think of, right? Just some of the approaches that they take. So I think creativity is key still. So play is important.
What? So ads, do you have one thing that you would suggest to folks to do?
Not just saying it. I was going to say just play with the tech, like get your hands dirty with it. Don't get stuck in the weeds. Although shiny rocks are awesome, like it's easy to kind of go down that path and start thinking that you've got some kind of incredible payload bank of prompts because it won't work elsewhere unless it is like a real like transfer attack. And look at the research papers. Actually, is actually my biggest piece of advice. Like, I am not academic or have any kind of academic background. It was difficult for me to make that switch from going from like looking at CTF write-ups or like blogs to research papers. But a lot of the attacks are based on research papers that have been published over the past 30 years. So I think like if you were to kind of take comparison of like reading an RFC for like TCP/IP, if you're a network engineer, I think like the alternative thing is to be actually researching the articles that have been published by like yeah.
Great. Ken, one thing, real quick.
Yeah, I would say in order to start the red team, it's very important what you red teaming against. Using the framework like cross-security alliance maestro framework that I developed is just some shameless plug here. I think it's really help to first see what kind of threat given the system or agentic AI system or AI system. Go into each layer to find out what could potentially be threat, and then prioritize some critical threat and do the red teaming like Jason has mentioned. Just play with it and see what coming out.
All right, Heather, one thing.
I think it's not just for red teams, but also for business leaders is don't put your faith in the idea that what is safe for everyone else, that these models have been tested by Microsoft or that they've been tested by Google or they've been tested by Anthropic means that they are 100% harmless for your individual use case, right? Just because you see an attack that worked out there with a prompt injection doesn't mean that applies to your particular use case. Our goal as red teamers and what should be our goal as businesses is to evaluate the safety of the system after it has been changed by what we have done to it. And I think that's a really important piece to keep in mind is that every use case is going to have some type of emergent socio-technological issue. And that's what we should be looking for.
Thanks, Heather. Well, and thanks everyone. I want to thank everybody on the panel here today. And for those who've been sending us messages to answer, hopefully we'll be getting to some of those. If we haven't got a chance to get to those, we will follow up with more questions. So once again, I want to thank our panelists for today, and I want to thank you all for joining us for this session.